Okay, let's talk about the average value of a function. Oops, let me balance there we go. All right. This is, so I consider this on the easy side, but yeah, so this is going to be a short video. So first of all, what are we talking about? What is conceptually, what is the average value of a function? So here's one way of describing it. So I drew the graph of a function on an interval from a to b, and imagine it looks like this. And let me ask the question, if I draw this picture on the right, which is just a rectangle, and the base is the same, it just goes from a to b, and the height is something that we're going to talk about, but I want to choose the height to make this area the same as this area. And that's one way of explaining what is the concept of the average value of a function is. It's just h. We're gonna call the value of h the average value of a function. One way of thinking of this is it's like if I have like a bathtub, like a horizontal bath, like a two-dimensional bathtub, I guess, and I'm giving my dog a bath and it's really splashing, like the water is all, there's waves in the water and everything. And then when we're done, I take my dog out and the water calms down and becomes perfectly flat like this. And it's the same amount of water, of course. How high is the water? That's one way of thinking about what we're doing here. So we're going to find this pretty easily. What value of h makes these areas the same? Well, this one has area, that's what integrals are for. It's the integral from a to b of f of x dx. So that's the area of this one. The area of this one is just the area of a rectangle, so the base is b minus a and the height is h, so it's that. And if I want to solve for h, I just divide by b minus a and I get this formula. So that was pretty easy. And h, like I was saying, h is what we call the average value of the function f of x over the interval from a to b. So I'm going to do an example. The truth is that if you can do an integral, you can find the average value. This is not a difficult setup. You take whatever function you're given and you stick it right here, you integrate it, and you just have to remember to divide by divide by b minus a, or stick a 1 over b minus a in front. So I describe this as easy because we've recently done examples where it's like finding the volume when you're revolving a shape around an axis of revolution, which requires a bit more thought when you set it up. This doesn't really require a lot of thought to set up. That's why I describe this as easy. As long as you're able to do this integral, you're good. Yeah, so real quick before I do this example, let me just explain another sort of like more conceptual thing, which is like average velocity. Like if I have a function that's telling me the velocity of an object at a certain time, and maybe it's going faster at some instance and slower at other instances, I can find the average velocity over some interval of time, like t1 to t2, and then if all I know is the average velocity, then I can still answer the question of how far the object went from time t1 to time t2, because I can just act as if, even though it went faster in some instances and slower in other instances, I can just act as if it went the average velocity the whole way through, and that will give me the same answer when I determine the distance that it traveled. Anyway, let's do an example. Like I said, this is going to be easy. I made sure to do this one where it's going to require a substitution just because I wanted to throw a twist in there, because otherwise this is too easy. So here we go. Here's my function, cosine 2x. Here's my interval, so this is going to be my b and my a. And like I said, setting this up is literally just, okay, a goes here, b goes here. I'm going to have a 1 over b minus a. f of x goes here. That's the setup. Didn't really need to think very hard. So let's do this. We do need to be able to do this integral. So, okay, pi over 2 minus pi over 4, that's pi over 4. And then, yeah. How am I going to do this? I want to do a substitution. I like to use the letter W for substitutions. We're going to find out why I love the letter W for substitutions in just one more video. But let me use the letter W. I let it be the inside of this composite function. That's 2x. dw is 2dx. And if I solve for dx, I get 1/2 dw. And so I'm over here, I'm going to write an integral in terms of w's. So, of course, this is just going to be cosine of w. That was the whole point of making this w. dx, I can replace dx with 1/2 dw. And then let's talk about what happens with these limits of integration. The way I'm going to do this is I change the limits of integration. That way, once I find the antiderivative, I can put the new limits of integration right in for w. Of course, what goes here is going to be whatever w value corresponds to this x value. W is 2 times x, so this w value is going to be 2 times this x value. So this is going to be pi over 2. Likewise, this one corresponds to this one. W is 2x, so I do 2 times that, so this one's just going to be pi. All right, moving right along. Let's see if I can pull this off in the amount of space I have. So where am I? So let me flip this fraction. So I'm going to have a 4 over pi times, okay, let's see. This 1/2 can pull right out, so I can write that, say there. Antiderivative of cosine is sine. And then I want to put in pi over 2 and pi. Okay, I can cancel a little bit of stuff here. So there's that. And then I'm going to have a 2 over pi. And then I put in pi. And then I put in pi over 2, like that. Let me just draw a little unit circle here. I don't really need a lot of information off the unit circle, but okay, an angle of pi is right here, and sine is the y-coordinate of the point. So sine of pi is the y-coordinate of this point, which is 0. Sine of pi over 2, well, pi over 2 is 90 degrees, that's this point, so it's the y-coordinate of this point, 1. And so this is negative 2 over pi. And for the average value of a function, getting a negative answer shouldn't bother us. The answer can be negative. If you graph this function over this interval, you will find that this does have negative values on this interval. So the average value of a function that's negative is going to give you a negative answer. Yeah. Okay, so I'm going to leave this video at that because it's like I said, as long as you can do an integral, you can find the average value. Like setting it up is very easy, and then it's just a matter of evaluating the integral. Okay.